which of the following is a table of values for f of x? So to check these problems, all you have to do is plug in the number for x and make sure it checks out for the y value. So this is saying this side of the equation is 3. This side of the equation is, whoa, that's not right, right? 1 to the third does not equal 3, so that's not it. Checking this one, if I plug in 1, I should get out 1. So I'm going to plug 1 in for f of x, and that should give me 1 to the third over here. That checks out so far. We got to check the next point. If I plug in 8, it says I'm supposed to get out 2 for a y value, for the f of x value. That doesn't work. So this whole thing is out. It has to work for every point. And so this one's correct because if you plug in each number, it's giving you the corresponding y value. If you plug in 3, 3 to the third is 27, so that checks out for all 4 of those. Okay, so that's really all you have to do. Plug in the value for x, see what it spits out for y, and make sure it matches up with what you see in the table. So f of x equals the absolute value of x. That's one of like the 6 basic functions that our course is trying to talk about. It looks like this. Okay, and the reason for that is you could make a quick table of values to see what the function looks like. If you plug in 0 into this function, absolute value of 0 is 0, right? If you plug in -1, the absolute value of -1 is +1. So -1, comma 1, there's our dot. 0, comma 0, there's a dot. If you plug in +1, you get out +1, there's our dot. So absolute values make that corner that we see right here. You could do the same thing for this one. Plug in some numbers for x, like let's plug in -2. -2 squared would give you +4. -1 squared gives you +1. Plug in 0, you get out 0. Plug in 1, you get out 1. Plug in 2. 2 squared gives you 4, okay? So that makes this graph right here. So 0, comma 0, that's a dot. -1, comma 1, that's a dot. -2, comma 4, that's a dot up here. 1, comma 1, that's a dot. And x squared graphs should always have a curve at the end, not a corner like that last one we just saw, okay? So that's a graph of y equals x squared, or in other words, a quadratic function. There's another one of those table of value questions. If you try to plug in -1 in here, the square root of -1 is imaginary, so it can't even fit on a graph. So I imagine that Newton doesn't even have that as an option. If you plug in 0, we can evaluate the square root of 0. If you plug in 0 right here, you get out 0 for a y value. 0 times 0 makes 0. If you plug in 1 in for x, the square root of 1, that's 1. So that is our y value. If you plug in 2, you get something yucky with a bunch of decimals, so don't do that. Plug in 4 for your next one. If you plug in 4 here, the square root of 4 gives you 2, so that's our y value. So the graph of y equals square root of x has these for dots. 1, comma 1, 4, comma 2. It always rises, but its rate of increase slows down over time. They're saying if you plug in -5, you get out -5 for a y value. So let's see which one of those are true. For this function, would that work? If I plug in -5 into this function, then I'm just plugging in -5 in for x. I plugged in -5 for this function, and I got out -5. So that works. Let's try this one. If I plug in -5 into this function, -5 gets squared. Uh-oh, that's not possible. -5 gives us 25 for this function, so that's out. And then this one, if I plug in -5, then I'm going to be doing -5 cubed. So that's -125. So that's not going to give us -5. If I plug in -5 into this one, then it's the absolute value of -5, and that gives us +5. We didn't get out -5 as a result, so this also doesn't count. So this is fx equals x. That's the same thing as y equals x. That's a line with a slope of 1 and a y-intercept of 0, like this.